The Earth did not begin as the world we know today. Long before modern oceans separated the continents, and long before borders divided the map, there was a single immense landmass joined together as if the entire planet had been shaped from one piece. It was Pangaea, a world of extremes, where vast deserts stretched across the heart of the supercontinent, while its edges were touched by ancient seas alive with movement, sound, and life. But no geological empire lasts forever. Beneath the silent surface, deep forces were already at work in secret, preparing the rupture of something that seemed unbreakable. At the center of Pangaea, the climate was harsh and unforgiving. Far from the moderating influence of the ocean, the interior grew hot, dry, and vast, a land of dust, wind, and endless distance. Yet along the margins, rivers carved fertile valleys, forests gathered around floodplains, and life adapted to a world that was united but never still. This was not a peaceful Earth. It was a planet under pressure. Below the surface, the slow machinery of the planet was already shifting. Tectonic plates pressed, pulled, and strained against one another. Ancient scars in the crust began to weaken. Heat built up beneath the great continent, and the ground that had once held everything together started to lose its strength. For millions of years, the change remained invisible. Then, little by little, the first cracks appeared. What followed was not a single moment, but the beginning of an irreversible transformation. Pangaea had ruled the Earth as one giant body of land. Now that body was beginning to split apart, and with it, the future of the planet itself was about to change forever. Long before the first cracks appeared, Pangaea had already lived through an entire history of collision. The supercontinent was not born in a single instant. It was the final result of hundreds of millions of years of continents drifting, colliding, and fusing together, one after another, like pieces of a puzzle forced into place by the slow violence of the planet. Mountain ranges rose where ancient land masses crashed into each other, their peaks marking the scars of unions that would later become the hidden seams of a much larger body. By the time Pangaea reached its complete form, it stretched across the equator in a shape unlike anything the modern world would recognize, curving like a great arc that wrapped around a narrow sea. To the north lay Laurasia, the ancestor of what would one day become North America, Europe, and Asia. To the south lay Gondwana, the ancestor of South America, Africa, India, Australia, and Antarctica. Between them, cradled inside the curve of the supercontinent, rested the warm and shallow waters of the Tethys Sea, a body of water that would play a quiet but decisive role in what came next. Life on Pangaea had already adapted to this strange, unified world. Across the dry interior, hardy plants clung to survival in conditions that offered little mercy. Along the coasts and floodplains, forests of ancient conifers and seed ferns created dense green corridors, home to creatures unlike anything alive today. Among them walked Lystrosaurus, a strange tusked survivor found not in one isolated region, but scattered across what would later become entirely different continents. Its presence in such distant corners of the modern world stands as living proof that these lands were once connected, joined by nothing but open ground. Beneath this world of deserts, forests, and strange animals, the true story of Pangaea's fate was being written in stone. The same forces that had pulled these continents together were never truly at rest. Heat continued to rise from deep within the planet, trapped beneath the thick, insulating shell of the supercontinent. Like pressure building inside a sealed container, this heat had nowhere to escape. It pressed upward, searching for weakness, testing every fracture, every ancient suture where continents had once been welded together during their violent formation. It was along these old scars, the very same lines where Pangaea had been forged through collision, that the first signs of failure began to surface. What had once been solid ground became a battlefield of invisible stress. Faults reactivated. The crust stretched thinner in certain regions, unable to withstand the growing tension from below. These were not sudden or dramatic movements. They were slow, patient, and almost imperceptible, unfolding over spans of time far beyond human comprehension. Yet within this apparent stillness, something irreversible was already taking shape. Pangaea, the single continent that had defined the surface of the Earth for tens of millions of years, was no longer simply enduring pressure. It was beginning, quietly and steadily, to come undone. The world above remained largely unaware of the transformation stirring beneath its feet, but deep within the planet, the process that would eventually tear this ancient land apart had already begun. As the strain deepened, Pangaea began to reveal what had always been hidden inside it. It was never a finished structure, only a temporary balance of forces. The great continent had looked permanent from above, but permanence on Earth is only an illusion measured against deep time. Beneath its deserts and forests, the crust was thinning, warping, and weakening in silence. The planet had started to pull apart its own creation. The first changes were subtle. In some regions, the ground slowly rose and sank. In others, narrow valleys formed where the crust began to stretch like fabric under too much tension. Rivers shifted course, basins deepened, lakes spread into low-lying depressions that had not existed before. At the surface, these changes could pass unnoticed to a human eye, but over geological time, they were the opening movements of a far greater event. The continent was beginning to fracture, and once that process reached a threshold, there would be no reversing it. Far below, the mantle continued to move with patient force. Hot material rose from the planet's interior, and where it met the base of the lithosphere, it weakened the rock from beneath. In some places, ancient suture zones, the scars left by old collisions, became the easiest paths for the stress to concentrate. These were the weak points, the lines where Pangaea would eventually split. The very seams that once stitched the supercontinent together now became the places where it would begin to fail. At the same time, volcanic activity started to mark the changing world. Magma forced its way upward through fractures in the crust, feeding eruptions that hinted at the violence hidden below the surface. The ground trembled in ways that had never been common before. Heat, pressure, and tectonic motion were no longer acting as separate processes. They had joined together in a chain reaction that would reshape the entire planet. What had once been a single connected landmass was now becoming a field of tension, a system under strain from every direction. The life that inhabited Pangaea remained tied to the rhythms of this world, but the rhythms were changing. Some species spread easily across the vast interior, benefiting from the lack of oceans to block their path. Others were confined to humid coastal belts, where the climate remained more forgiving. Yet even these ecosystems were not isolated from the larger transformation. As the land shifted, habitats changed with it. Rivers moved, coastlines changed shape. New environments appeared while old ones disappeared, forcing life to adapt or vanish. What made this moment so remarkable was not speed, but inevitability. Nothing in Pangaea failed overnight. The process was slow, almost unimaginably slow, but it was also relentless. Each small fracture weakened the next. Each rising pulse of heat made the crust more vulnerable, and with every passing age, the possibility of separation became more certain. Pangaea was still whole, but not for much longer. The first wound had already been made, and the ancient continent had begun to move toward its final transformation. Beneath the surface, the breakup of Pangaea was already becoming impossible to stop. What had begun as invisible stress was now a physical reality, written into the shape of the land itself. The crust no longer behaved as one continuous body. It bent, it cracked, it thinned under the immense pressure of forces rising from below, while the supercontinent above struggled to hold itself together. Across vast regions, the ground stretched in long, weakened zones. Fault lines multiplied. Great rift valleys opened where the land pulled apart, and with them came new basins, new lakes, and new routes for sediment, water, and eventually oceans to occupy. These were the early wounds of a planet changing its skin. They did not appear all at once, nor did they announce themselves with a single catastrophe. Instead, they spread gradually, a system of fractures widening across a world that had once seemed stable. As the crust continued to thin, magma found easier paths to the surface. Volcanic activity increased, not everywhere at once, but in pulses, each one revealing how much pressure the planet had stored beneath its outer shell. Some eruptions were local, while others hinted at something larger moving through the deep earth. The land shuddered. The air grew heavy with ash and gas. In the regions nearest the active rifts, the ground became a place of constant change, where no landscape could be trusted to remain the same for long. At the same time, the climate began to respond. Pangaea's immense size had already created a harsh interior, but as the supercontinent started to fracture, the balance between land, sea, and atmosphere shifted again. Coastal zones evolved, monsoon patterns changed, and new seaways slowly began to form where there had once been only solid ground. The world was not simply breaking apart in a physical sense. It was also reorganizing the circulation of heat, moisture, and life itself. For the creatures living across Pangaea, these changes were both opportunity and threat. Some species moved easily through the connected landmass, crossing great distances without ever meeting an ocean barrier. Others depended on narrow environmental conditions, living in floodplains, forests, or humid margins that were becoming increasingly unstable. As the rifts deepened and the climate shifted, the geography of survival began to narrow. Habitats were no longer permanent. Rivers carved new paths. Forests retreated or advanced. Regions that had once supported rich ecosystems were slowly transformed into something else. And yet, from the perspective of deep time, this was still only the beginning. The full separation had not yet arrived. No vast ocean had opened completely. No continent had drifted far enough to lose contact with its neighbors. But the direction was already clear. The supercontinent had entered a new phase, one defined not by assembly, but by division. What made this transformation so extraordinary was the scale at which it unfolded. A human lifetime could not measure it. Even civilizations would not be long enough to witness it. But Earth kept its own clock, one marked by pressure, heat, and motion deep within the planet. And on that clock, the end of Pangaea had already begun. The change that had been building for so long finally began to take on a new and irreversible shape. The cracks in Pangaea widened, the rifts deepened, and the land no longer resisted as one body. What had once been a single connected world was now becoming two, then many. The pressure that had held the supercontinent together was giving way to something stronger than its silence: movement. In the regions closest to the growing fractures, the landscape turned unstable. Valleys stretched longer, basins sank lower, volcanoes marked the faulted ground with fire and ash. The crust, once thick and unified, was now so weakened in places that it could no longer conceal the power of the planet beneath it. Magma rose more easily through the broken rock, feeding eruptions that hinted at a deeper upheaval still to come. The surface of Earth was no longer a fixed stage. It had become a living system, restless and unfinished. As the separation advanced, the oceans began to answer. Where there had been only narrow rifts, seawater slowly found its way in. The first openings were small, almost invisible on a planetary scale, but they were enough to mark the birth of something new. A new ocean does not appear all at once. It begins as a crack, then a basin, then a widening corridor filled by water and time. This was how the future Atlantic came into existence, not as a sudden event, but as a long unfolding of space between once connected lands. The old interior of Pangaea started to lose its authority over climate. Air currents shifted, heat and moisture were redistributed. The great desert heart of the supercontinent was no longer the only defining force on the planet. As the landmass split, more coastlines formed, and the relationship between sea and sky changed with them. Rainfall patterns transformed. Monsoons evolved. New ecosystems emerged along the margins of the opening world, while others disappeared beneath the pressure of change. For the species that had once moved freely across one continuous landmass, this transformation carried both danger and promise. Some populations became isolated. Others found new corridors into regions they had never reached before. In the broken world that followed, evolution would no longer be shaped by a single continent, but by distance, separation, and the slow invention of barriers. The future would belong to those able to adapt to fragmentation, to changing climates, and to the consequences of living on drifting pieces of a once unified planet. Still, the Earth did not rush. The process moved with the patience of geology. It was measured not in days or years, but in millions of years of pressure, release, and rearrangement. The continent that had once seemed eternal was now being rewritten from the inside out. Pangaea was not simply breaking. It was becoming the world that would follow it. The world that emerged from the breakup was unlike the one that had existed before. The giant connected landmass that once governed climate, migration, and geography was gone, replaced by separating continents that would drift farther apart with every passing age. What had been a single planetary body was now a mosaic of shifting edges, widening seas, and new coastlines slowly taking shape in the silence of deep time. In the regions where the crust had split most completely, ocean water continued to flood the gaps. What began as narrow rifts became young seas, then growing oceans, their basins deepening as the continents moved away from one another. The Atlantic, still young in this part of Earth's history, was not yet the wide ocean known today. It was a widening wound, a space between old neighbors, filled first by water and then by the rhythms of currents, tides, and marine life. Every mile of separation marked a loss of contact between once shared ecosystems and a gain of new environmental possibility. On land, the consequences were just as profound. Regions that had once sat deep inside the supercontinent were no longer trapped in the same climate regime. New coastlines softened the extremes that had ruled the interior. Moisture could travel farther inland. Seasonal patterns changed. The dry heart of Pangaea gave way in some places to more balanced environments where forests, floodplains, and river systems could expand. The planet had not become calmer, but it had become more varied. With variation came diversity. Life responded with its own long and patient transformation. Some groups disappeared, unable to keep pace with changing habitats, volcanic disruption, or shifts in temperature and rainfall. Others survived by adapting to the new geography. Isolation created difference. Separation created opportunity. The fragments of Pangaea no longer shared a single evolutionary fate. Instead, each drifting continent began to write its own biological story, shaped by the climate, the oceans, and the living communities that remained behind. This is why the breakup of Pangaea mattered far beyond the movement of rock. It reshaped the map, but it also reshaped the rules of life. The same processes that tore the supercontinent apart opened the door to a new world of distinct continents, distinct climates, and distinct futures. The planet became less unified, but more complex, less connected, but more alive with variation. And even now, that transformation is not truly finished. The continents continue to move. Oceans continue to widen and close in the long rhythm of tectonic time. Mountains still rise where plates collide. Seas still form where the crust stretches and breaks. Pangaea is gone, but its legacy remains written into every coastline, every mountain chain, and every fossil bed that remembers a world before division. What began as a single landmass ended as a planet divided into moving pieces, each one carrying the memory of the whole. And from that division, the modern Earth was born.